Question number 16. A cube of side 1.0 centimeters has a resistance between the opposite sides of 50 ohms. The material is reshaped into a block of length 4.0 centimeters and constant square cross section. Right? So that's the first 1 meter we are seeing there. And that is a reshaped one that is giving us a new length, which we can also call the height to be 4.0 centimeters. The question is asking us, what is the resistance of the block between its square ends? That is for the new reshaped figure that we have. We are asked to find the resistance of the block between its square ends. All right, so let's jump. This looks like a very simple solution, but then you have to be very careful when you are doing this one. So let's jump into the solution. The first thing you have to know is the definition for resistance. So resistance is given as resistivity times the length divided by the cross-sectional area. So for the cube of side 1 centimeter, we can find the area to be 1 centimeter squared, and we can find the volume to be also 1 centimeters cubed. So using the area and then the resistance we've been given, which was 50 ohms in the question, we can say 50 is equal to resistivity multiplied by 1 by 1, and that should give us the resistivity to be 50 ohm per centimeter. 50 ohm per centimeter. Now the cube is reshaped into something that is rectangular. And the question made mention of constant square cross section. What this means is that when the new shape is cut across its length perpendicularly, the face you will see is that of a square. And that is not to say that the dimensions of the first square will be the same as the dimensions for the second square that we are getting when we slice through the second shape. No. But what the constant square cross section means is that when we slice a new shape, that we were given, and the new shape that we're given is this. This is a new shape that we're given. So when we slice this new shape that we are given perpendicularly in this way, let me draw a good, so this way, something straight like that. If you slice it perpendicular like that, the shape you will see from the side should be that of a square. That is what the question is saying. All right, so once we know one side is a square, we've been given the length, which we can call our height, to be 4 centimeters. So let's use volume to find this new cross-sectional area. Now, you realize that we found the volume here for the cube to be 1 centimeters cubed. So we are writing the volume is equal to new area times the height, which is the same as the length we're given in the question. Okay, but then we are using the same volume of the 1 centimeter because now the object we have is the same material. We've not added anything to it. So reshaping it does not change the volume of the object. So we are using 1 centimeter cube. So 1 centimeter cube is equal to the new cross-sectional area multiplied by 4. And that should give us the new cross-sectional area to be 0.25 centimeters squared. Okay. Now let's fix these values and find the new resistance in the new shape. So the new resistance is given as resistivity we found was 50 ohm per centimeter, and we are using the same 50 ohm because it is the same material, and once it's the same material, resistivity will not change. It's the same resistivity. So 50 multiplied by 4 divided by 0.25 should give us 800 ohms. So the new resistance for the new shape we have is 800 ohms. So let's jump back to the question and see which one has this answer we've just gotten. So A, B, C, D. Our correct answer here is C. Good. All right. See you in the next video.